fine. We've sort of gotten over it. Organic for most people means a vegetable grown without pesticide, which is not actually true. Just it can't have certain pesticides, and the quantity of the pesticides it can have to be low. Um, and it's sort of, but doesn't actually mean non-GMO. It just means sort of like healthier food, right? Supposedly. The name was actually coined by a person named Alice Waters, and she's a phenomenally important cultural character in the United States. She opened a little restaurant in Berkeley, like Chez Louis or something like that. And what she did was she had no menu. Her and the other people that cooked the food, they woke up at like 5 o'clock in the morning, and since this was in Berkeley, they went down to the fisherman's wharf and they found fish or shellfish. And then they went to the closest farmer's market that opened early and they bought fruits and vegetables. And then they went to another market and bought grains and whatnot. And then they went back to the restaurant and said, what are we going to make with this? So everything that they had at the restaurant was locally picked up. It didn't come from, I don't know, the tomatoes don't come from Mexico. The tomatoes came from Sacramento Valley. They were driven in that day. So it's sort of disingenuous because she had access to all of that food that was locally grown because it's California. I mean, you can't do that in Wyoming. There's no crab in Wyoming. There's no tomatoes grown in Wyoming. But this brought the idea of you don't have to have food come from faraway places. Eat what's local. And so then the word organic came out of this. What it means for us is something super specific. Organic means carbon, not +4 oxidation state. All carbon is organic except for carbon with an oxidation state of +4. Okay? So are potato chips organic as far as a chemist is concerned? Yeah,
Yes.
there's carbon in it, and the carbon isn't +4 carbon. So what do you have to have a carbon with the charge of +4? All right, so what's going on? Why won't you let me switch? Sorry, I'm going to stop sharing for a sec. Oh, that's right, because I'm in stupid. All right, not bad. I'm going to switch over here, go to here, Control A, delete, share screen 2. So tell me about a carbon atom. Everything you know about a carbon atom.
It weighs 12.0 AMU.
Um, one isotope has a mass of 12 AMU. Tell me something
It
definite about the carbon atom.
It can make 4 bonds.
Okay, 4 bonds. Oh, goodness. What else we got? Something super fundamental. How about the thing that makes it the carbon atom?
It's got 6
It
protons.
has 6 protons. I know that for a fact. I don't care about the neutron number. Doesn't matter. It could be 6, and that's regular carbon. It could be 8, could be 20. Well, actually, it probably can't be 20, but it doesn't matter. What I care about is the fact that it's got 6 protons. So how many electrons does it have?
6.
It's got 6 electrons. That's a carbon atom. So if I'm a carbon atom and I've got +6 in my nucleus, and around the exterior, I've got 6 electrons, how do I get to be +4?
You take 4 of those.
So
Yeah, you took 4 of those.
these 4 electrons disappear, right? The electron configuration is 1s2, 2s2, 2p2. So the 2s2 electrons and the 2p2 electrons are gone, and then I'm left with the two 1s2 electrons. So my charge is going to be a +4. We okay with that? Because now it's only got these 2 negatives and it's got these 6 positives. Okay, so what is the maximum number of electrons that a carbon can have?
Eight. 8?
10.
Or is it just 6?
10.
Oh.
Right? It can get all the way over to neon. So it can gain 4 electrons. So what are the possible oxidation states for carbon? It can be as high as +4 and as low as -4. Okay? So what's the difference between these two things? Fundamentally, how do I get from one to the other? If I'm at +4 carbon, how do I get to -4 carbon?
You add electrons.
How many?
6, 10.
8.
8.
Right? Negative +4 gets me to 0, 4 gets me to 0, and then 4 more gets me to -4. Because these 2 electrons here, I can't touch those. Those are the helium electrons. Those are the 1s2 electrons. They're off limits. So a carbon atom can have as many as 10 electrons and as few as 2 electrons. So it can go from -4 down to +4. If I'm carbon and I am carbon +4, I'm not organic. So to be organic carbon, what must my carbon be able to do?
Lose electrons.
Lose electrons. That's it. If I'm organic carbon, that means I have the ability to give my electrons away. When you eat potato, your body takes the carbohydrate and uses the electrons on the carbon to make ATP recharge. We okay with that? So what happens if you bring in a carbon that doesn't have any electrons that are usable on it? It can't do anything. So this carbon, usable. This carbon is all used up. Dead battery. Charged battery. Okay? The more electrons the carbon has on it, the more organic it is, because that means it can donate more and more electrons. The most organic molecule in the universe is this molecule. Why? Because each of the hydrogens has a +1 charge. So that makes the carbon a -4 charge. So what is this substance?
Methane.
That's methane gas. So methane gas has the most bang for your electron buck. So what is the worst carbon? Give me a form of it. So you eat a potato chip and it comes in
Carbon
as a
dioxide.
carbohydrate and you breathe it out as CO2. So it's oxygen double bonded to a carbon, doubly bonded to an oxygen. You're -2, you're -2, you're +4. Why are you exhaling carbon dioxide? Your body has consumed all the usable electrons on the carbon. So you need to get rid of it. And the plant says, I need a place to shove electrons or I'll burn up in the sun. So it takes carbon dioxide in and shoves electrons back on it so it doesn't burn up. And then makes carbohydrates. And then we eat those carbohydrates, pull those electrons off, and then send the carbon back to the tree. Everybody good with that?
Yep.
So here's methane, has all possible electrons. Here's methanol, it lost 2 electrons. Here's formaldehyde, it lost 2 more electrons. Here's acetic acid or methanoic acid, it lost 2 more electrons. And now we're here at carbon dioxide and it's completely used up and there are no electrons to be used in the carbon. You okay with that? This is sort of the decay sequence of electrons for carbon. All right, so do you guys know what this phrase means?
Vital force theory?
Yeah. It means things that living organisms can make them because they have a soul. And that means that you can't make them without a living organism, which means you can't make them in a lab. So can we not make organic molecules in a laboratory? Of course we can. We absolutely can. Vital force theory was sort of like a so my daughter was trying to throw rings on this ring game yesterday. And at some point she was like, I can't do it. Forget about it. She turned around and stomped off and then act like she was in timeout. Put herself there. I can't do it. It's too hard. That's what vital force theory is. Scientists acting like children. This is too hard, so we must not be able to do it. That's it. Instead of continually trying to figure it out, they're like, it's against nature and it can't be done. All right. So most people who consider themselves chemists or scientists were trying to disprove the good ones. We're trying to disprove vital force theory. So this guy down here, Wohler, he had the unenviable task of working with a guy who was working with urine. So what he saw a lot of was urea. He saw a lot of crystallized urea. He could look at crystallized urea coming out of a canister and say, that's urea, and just know it because he's seen it so often. So after he left this person that he was working for in Sweden, he went to France and he started working on projects. And him and this other guy took ammonium cyanate and created urea from it in a lab. And the moment that happened, Wohler said, that's urea. And the other guy's like, how are you sure? He's like, hey, you know who I worked for. You know how much piss I had to work with. You know I know what urea looks like. And then they both looked at each other and said, what did we just do? We just disproved vital force theory. So then Wohler took this experiment and he went around to all of the major universities in Europe and said, hey, I know you believe and the rest of the world believes in vital force theory. Give me some ammonium cyanate. Watch me. What's that? Urea. Where does urea come from? A person. Okay, so I just created a molecule that's created in people. So vital force theory? And they're like, all right, we're out. It's stupid. We're over. So then he just kept going from university to university, convincing all the famous and important chemists and physicists and scientists that vital force theory was out. And as soon as that happened, what did the rest of the scientific community start doing? Making stuff. So do you remember what happened when the periodic table was first created and he left holes in the periodic table and said, we're missing elements? They're like, we're missing elements. Let's go find elements. And they went out looking for elements and they found them almost immediately, like within a year, because they knew what they were looking for. They were looking for something that behaves like carbon and silicon, but's heavier and a little more metallic. And they went and did some experiments until they found it. And bang, germanium is found. German chemists found it. So as soon as this happened, people started making organic molecules. So why did they think that organic molecules were not something that could be created?
Because it was difficult to make.
So this is a graphical representation of hemoglobin. Does that look like something you want to make?
We can't see your screen.
This is a graphical representation of hemoglobin. Does that look like something you want to make?
No.
These are ribbons or protein structures. These are heme molecules. The heme molecule in itself is huge. I have 4 heme molecules in 4 separate protein structures. The yellow and the yellow are mirror or copies of each other, and the reds are copies of each other. And then they all have to come together in that shape, meaning when you make it, they still have to have that shape. Do you think that humans would like to be able to make hemoglobin in a lab?
Yeah,
Why?
because then we would have more blood. And then
We would have as much blood as we want and whatever blood type we'd want, right? We wouldn't have to have blood donors. We wouldn't have to have people catch like Hep C. Before Hep C was a thing, before we knew what it was, people got Hep C from blood transfusions. Or maybe there's a Hep D that we haven't found yet, and it's out there right now. And people are actually getting it because they're getting blood transfusions. And in 10 years, we're going to be like, oh crap, these people are dying from Hep D, from a hepatitis, and we're going to call it Hep D. Wouldn't it be nice to be able to just make it in a lab and there's no virus there? Of course. Wouldn't it be nice if somebody took a gunshot wound in, I don't know, Afghanistan, and the medic there had a 20-gallon container of type O blood? So the guy's literally leaking. And it doesn't matter because he just keeps filling them up. Can't die if I just keep pumping blood into you. right?
Yeah.
So, yeah, we'd really like to be able to make it, but we can't. And we haven't. And we've been trying to make this for more than 100 years. Haven't been able to do it. So it's understandable that you could say, hey, I'm just going to give up because this is too hard, because it is really hard, but you still shouldn't do it because at some point, some company or somebody at a university is going to make hemoglobin and they're going to become an instant gajillionaire and save, I don't know, untold thousands of lives. Because what if you're one of those blood types that's rare?
You better start stocking up on your own blood.
They People will actually have blood pulled for themselves and put in a blood bank near them. And they're like, I don't want this going on. Or they might freeze it in a particular type of lab, and then somebody will go get it and bring it to the hospital if you need it because the blood type is rare. Okay. So organic molecules are any molecules with carbon in them as long as the carbon doesn't have a +4 charge. And organic molecules are hard to make. And organic molecules do not have a soul. All right? We all good with that? We learned that in like 1928. There's an entire realm of chemistry called natural product synthesis, meaning, so you guys are supposed to be writing a paper about a molecule that's biologically active, right? So why would a person want to drink green tea?
Contains caffeine.
And other molecules that are biologically active. So
Delicious.
living organisms create molecules that can work in other living organisms. So what if we find a molecule that's in a slug, and that slug, this molecule inside that slug cures pancreatic cancer? Does that mean we have to grow all of these slugs and slaughter them for their molecules? Or would we like to be able to take that molecule and make the molecule and stop killing the slugs?
Yeah.
That'd be great. Does anybody know what drug is used right now as a blood thinner to save people from cardiovascular death that's created in the weirdest way?
That's the one that comes from pigs, isn't it?
Warfarin is a highly used medication that comes from the intestines of pigs. In China,
Ew.
they have these farms where they grow pigs as large as possible to give the largest digestive tract possible. Then they slaughter the pigs for the intestines. Then they scrape these molecules out of the intestines and they extract warfarin out of it. We can't make it in the lab, but warfarin saves lives, saves people's lives long enough to get them like an organ transplant. So that's just an easy example. We don't want to have to make these pigs in a particular way, and they're special pigs. Like, they're basically only allowed to breed with each other because I can't have any genetic defects in their intestinal tracts, or changes, not necessarily defects. Okay, so we'll talk about carbon's Lego-ness when we come back on Thursday.
Oh man.
See you guys Thursday.
See you Thursday, Professor. Don't forget to post the homework.
Have time.
I always post the homework. I just don't always post a way for you to post the homework
No,
back.
you forgot the homework once.
Okay, once. Sorry. I'm fine with that.
Bye, have a good day.
But it's your
But
job
then
to tell
you
me I
blame
forgot to
Sheen.
post it.
But then you blame Sheeny.
It was
No.
my fault though.
It's always Sheen's fault.
It was Shane's
literally-
fault when we all met in class.
I thought it was Annika's fault.
It's not always my fault. It's always your fault, and it's my job to correct it.
I mean,
Oh,
it sounds like an Annika problem.
I'm gonna have to agree
Danger
with
will
it.
sue you.
Try it. I already have a Sue in my house.
Alrighty.